This is Wells Math, and I'm going to show you how to multiply when you're using numbers with decimals in them. It's really not that bad, just a couple of the rules you have to remember. So let's work a few sample problems. Let's look at our first problem. I'm going to write this out. If you look at the star, it says line up the last number, and then we'll count our loops. I'll talk about what that means here in just a second. So let's write this problem. I would write this problem down with me. 7 and 27/100 times 4.3. So if you notice, we just lined up our last numbers. So when you're multiplying with decimals, you're going to write your numbers just like pretending the decimals aren't even there. Now, that is different than adding and subtracting decimals. Totally different rule with that. You have to line those decimals up. But when multiplying decimals, line up your last number. So we're just going to go ahead and work this problem just like we would if there were no decimals in it. And then when we get to our answer, that's when we're going to have a little rule that you're going to have to remember. So we're going to take our 3 and multiply it times everything on the top, starting with the 7. 3 times 7 is 21. We'll carry our 2, bring down the 1. 3 times 2 is 6, plus 2 more is what, 8? And lastly, 3 times 7 is 21. We have no other number to carry it to over here, so the 21 will come all the way down. Okay, and I'm trying to keep my numbers kind of lined up in rows. If you see what I'm doing here, kind of spread that problem out a little far. All right, we're done with the 3. We'll move over to the 4. But since we're moving over a place value, we must add a 0 right here before we start multiplying our 3. If you do not do that, you'll get the whole problem wrong. So just try to remember that. All right, so now we're going to take the 4 and we're going to multiply it times everything on the top, but we have to go in the same order as we did the 3. So we'll do 4 times 7 is 28. To mark out that 2, so 28. 4 times 2 is 8, plus 2 is 10. We got to carry the 1, bring down the 0. And then lastly, 4 times 7 is 28, plus 1 is 29. Remember, your numbers need to be lined up correctly. Had students that don't do that, and then when they get to this part to add these numbers up, they get all confused on which numbers they're supposed to be adding. So let's see, let's just do a quick addition. 1 plus 0 is 1. 8 plus 8 is 16. We'll carry that 1, bring down the 6. 1 plus 1 is plus 0 is 2. 9, 10, 11. We'll carry the 1. 2 plus 1 is 3. So here we have our numbers. So we've done all the tough stuff. This is what you have to remember now to count your loops, because this number is going to have a decimal in it somewhere. How do we know where that decimal is going to be? Here's what you're going to do. You're going to start at the end behind the 7 right here. You're going to make a loop for each number until you get to the decimal. Okay, the decimal was right there. I just made 2 loops right there to get from the end of the 7 to the decimal. Now I'm going to come down to behind the 3 and I'm going to do the same thing. I'm going to make 1 loop per number until I get to the decimal, which is like the stop sign. Well, that's only 1 loop right there. Okay, I have a total of 3 loops in my problem. There was 1, there was 2 on top, and then there was 1 right there. So there were 3 total loops. What are you going to do? You're going to come down. You're going to start here at the end of the 1, and you're going to make 3 total loops and put the decimal right there. 31.261 or 31 and 261 thousandths if you want to sound fancy. Okay. Let's do another one of these problems very quickly. But like I said, you're working the multiplication problem just like normal, like the decimals aren't there. And then you are counting your loops, how many loops are in the actual problem. That's how many loops will be in your answer, and that's where your decimal will go. Let's try one more. 4 and 382 thousandths times 0.53. Remember, we are just lining up the last numbers when you're multiplying with decimals. I'm going to go a little bit faster on this one. We're going to start with our 3. 3 times 2 is 6. 3 times 8 is what? 24. Carry the 2, bring down the 4. 3 times 3 is 9, plus 2 is 11. Keeping my numbers in perfect columns, everything is lined up perfectly. 3 times 4 is 12, plus 1 is 13. There's no place to carry the 1, so we'll bring the entire 13 down. Once again, we're going to add that 0 right here since we are moving over a place value. Now we're going to start multiplying the 5 times everything on top, but you have to start in order from right to left. 5 times 2 is 10. Carry the 1, bring down the 0. 5 times 8, 40, plus 1 is 41. 5 times 3 is 15, plus 4 is what? 19. Carry the 1, bring down the 9. And lastly, 5 times 4 is 20, plus 1 is 21. We're going to have to move over for a new place value there. Now we are ready to add our 2 rows of numbers. All right, we got our 6, got our 4. 1 plus 1 is 2. 9 plus 3 is 12. We will carry the 1, bring down the 2. 1, 2, 3. Add those 3 up, and then bring down our 2. But where's our decimal going to go? This is not our actual answer. These are the numbers in our answer. This answer has a decimal in it. What are we going to do? We are going to count our loops. We're going to start at the end of the 2 and make 1 loop per number until we get to the decimal, which is like the stop sign. So there were 3 total loops in that first row of numbers. We'll come down to the second number. 1 loop per number. We had 2 loops in the second number. How many combined loops in both numbers? There were 3 in the first row, 2 in the second. That's a total of 5 loops. So we will come down to our answer, start at the end, and we are going to make 5 loops. 1 loop per number. There's 3, 4, 5. Our decimal goes right there. So the answer to this problem, 2.32246. Seems like a really long number or large number, but it's really not. It's a 2 and then part of another number. Okay, so not too bad. Just remember, line up your last number, do the problem, multiply, and then count your loops in your problem, and then put that many loops in your answer. I hope this has been helpful. Y'all check out my YouTube channel at Wells Math. I would love for you to subscribe to that. I got tons of videos. Hopefully this has been helpful for you today. Have a great one.